Defining the C7 language with Flex and Bison. There are three main goals of this project. The first one will be to define the regular languages that will accept the provided constructs in the C7 language. We will use the lexical analyzer Flex for this purpose. The second one is to define the context-free grammars that will accept properly formatted C7 files. We will use the parser Bison for this purpose. And lastly, we will create an abstract syntax tree with the parser to connect each construct to form a single program. There are some similarities between the syntax of C7 and the C language, but there are also some differences. For example, there are keywords to begin and end functions and control statements instead of open and closing braces. And we must be able to recognize these types of tokens to create the keywords, types, functions, control statements, and identifiers that obey the C7 syntax. This slide gives some examples of regular expressions for C7. On the left you've got the tokens that we want to try to find, and on the right the corresponding regular expression to find these tokens. And the ones for the keywords are fairly straightforward, but the ones that identify like an integer or a float or an identifier are a little more complex, but they're shown there on the right, and these are the regular expressions that Flex will use. Flex will apply a given rule whenever it encounters one of the regular expressions that you set, and it will also return each token it encounters separately. Flex will generate an error when it encounters a token that does not match a regular expression that you do set. Here is a code snippet from a Flex file showing some of the regular expressions that are used in the C7 language. Once the tokens are returned with Flex, we must decide what to do with them, since of course the tokens themselves don't have a lot of meaning by themselves. And then once the grammar is defined, we can parse input and determine if it obeys the C7 syntax. A context-free grammar can be developed to recognize the different constructs of the C7 language, and to define this grammar, it's easier to start with simpler constructs of C7 and work our way towards more complex ones, using simpler grammars as building blocks. Here are some example grammars for the C7 language, showing the grammars to accept numbers and variable types and arguments for functions, as well as expressions and function calls. With the grammar defined, we can now use Bison. Bison will take the tokens returned from Flex and attempt to use the grammar's production rules to match the given tokens to a given construct of the language. Of course, if no match is found, then that means that there is a syntax error in the input. And depending on how we code the Lexicon parser, we can make it where our parser reports what line number the syntax error occurs on. Here is another code snippet, but this time of a Bison file, and it shows some of the grammars that are used. We can use Bison in our Bison file to create the abstract syntax tree by simply creating nodes of the tree in the rules for each part of the grammar. And there's an example shown here. We use C++ with Bison because C++ is very appropriate for modeling tree structures. The tree will be represented in memory, and we can deal with problems that Bison doesn't really deal with, like scoping rules and whether a variable has been declared before. Though the language in the image isn't C7, this image shows what our abstract syntax tree might look like graphically. Once the lexer, parser, and abstract syntax tree has been implemented, an interpreter can be created so that C7 code can actually be ran. With help from tools like Flex and Bison, along with the understanding of regular expressions and context-free grammars, simple languages can be created to follow your own chosen syntax. And finally, the compiler problem is a great and practical application of regular expressions and context-free grammars, and us programmers often take the compiler for granted.